Thank you for watching our video on the Network Administrator's Guide to SNMP. SNMP is a protocol used to access the network management and monitoring features of routers, switches, servers, and printers. SNMP has been a feature of network management for over 4 decades. Here is the Network Administrator's Guide to SNMP to help you increase your understanding. SNMP as a communication protocol is a standardized language used to request information from network devices and provide responses. SNMP allows network administrators access to most features of the network device, allowing real-time information to be processed and monitored. This live monitoring allows devices to be managed for performance, results, and troubleshoot issues quickly. SNMP was developed in the late 1980s by the Internet Engineering Task Force, IETF, to simplify network management by providing a common language to communicate between devices on different networks. The SNMP protocol has undergone several revisions over the years, with SNMP v3 being the current version. SNMP is implemented in almost all manufactured network devices and must be enabled by the user. Automated network management software tools can enable large quantities of network devices simultaneously, simplifying this process. SNMP has 3 main versions: SNMP v1, SNMP v2, and SNMP v3. The differences between these versions mainly revolve around the types of security mechanisms implemented, types of message formats, and supported operation commands. SNMP v2 is very popular but is less secure than SNMP v3. SNMP v3 is more secure than the other protocols because it implemented several security features: encryption, authentication, and access control. It also introduced new message formats and operation commands that make it easier to manage network devices. SNMP components include network devices, agents, and managers. Network devices such as routers and switches contain SNMP agents, which are responsible for collecting and storing information about the device. The managers are responsible for requesting and receiving information. The communication between agents and managers implement an SNMP protocol. The SNMP architecture uses a client-server model. The network devices act as servers, and the managers are the clients. The agents act as an intermediary between the network devices and the managers and are responsible for providing the information, requests, and information. The SNMP architecture is highly scalable, and this protocol has made it possible for large organizations to manage their network easily and quickly. Before you can start using SNMP, you need to enable it on the network devices you want to manage. Most devices may have SNMP enabled by default, however. You may need to configure some settings such as community strings, version, and traps. SNMP managers request information from the network device, and the SNMP agents are responsible for collecting information. This information can be CPU usage, memory usage, interface status, and others. SNMP agents and managers communicate using SNMP messages. These SNMP messages contain the requested information for the network device. This process of communication provides the requested information back to the network administrator. Community strings are used to control access to device information. SNMP uses 2 types of community strings: read-only and read-write. The read-only community string allows an SNMP manager to retrieve information from the device, while the read-write community string allows the manager to modify settings on the device. SNMP v3 provides authentication and encryption of SNMP messages and is recommended for use in production environments where security is a concern. The SNMP agents can be configured to send notifications to managers when a specific event occurs. The event can be when a device's interface goes down, when the device's CPU utilization reaches a certain threshold, or other events. These notifications are called SNMP traps and are used to alert network administrators of network issues. SNMP traps are also able to send notifications to multiple managers. This allows for redundancy and added failover. The information provided by the SNMP trap can include specific information about an event, time occurred, and severity of the issue. The Simple Network Management Protocol, SNMP, implements a number of commands and operations to capture and provide information to network management teams. Here are a few of the common commands. 2 of the most commonly used SNMP commands are SNMP get and get next. The get command retrieves a specific value from an agent, and the get next command retrieves the next value in a sequence. These commands are used to retrieve specific information from SNMP agents. This could include the status of network device, the number of errors that occurred on it, amount of traffic flowing through a network, and other network information. The SNMP set command allows network administrators to modify settings on a device. Please note that not all devices support this command, and if they do support it, be aware that this command can cause major issues with a device's setup. The SNMP set command is used to change the configuration of a network device. This could include changing the IP address or the SNMP community string. The SNMP getBulk command is used to retrieve multiple values from an agent in a single request. This command is more efficient than using multiple get or getNext commands. The getBulk command is particularly useful for retrieving data from large tables, such as routing tables or MAC address tables. The SNMP inform and trap commands send notifications to managers when specific events occur on the device or network. The main difference between inform and trap commands is that inform requires an acknowledgement from the manager, while the trap command does not. In conclusion, every network administrator should become familiar with SNMP, its commands, and architecture. Thank you for watching our short video on the Network Administrator's Guide to SNMP. You can find out more information on networks and network mapping at UVexplorer.com.